Welcome to another Great Cow Basic demonstration. This is part 6 of the PIC16F171 chip family tutorials, demonstrations. They show you what the capabilities are of Great Cow Basic. So this is part 6, and today let's get straight into. Now, you will notice here on the screen I've got a little fox's head. I'll explain that later. And we have a new logo for the cow. And you'll see this appear more and more often as we release our products. Great, let's have a little pull up the camera. Hi, so my name is Venn. I'm one of the co-developers of Great Cow Basic. There are a whole suite of other people involved. I'm just doing the videos. So let's get into the PowerPoint itself and get into the start. So this is all about using the reset switch. We used a switch in the previous video. Now we're going to be able to use that as a multifunctional switch. We're going to use it as an input and a reset, and I'm going to show you how to do those two things. What am I using? I'm using a microchip, a low pin count demo board. There is the URL on the screen there and in the PowerPoints, which I shall publish, but you can create your own on a breadboard like Chris Roper has. I will show you mine. This is the board, this board here. Today I've got a PIC3 attached, and here is the chip. This is a 16F17126, and it's got these LEDs. It's holding these LEDs on. I believe that's where we left it yesterday. I pushed a switch, and magic happens. The LEDs go on and off. So let's just do that again. There we go. And that's where we left it yesterday. I pushed a switch. The LEDs go on and off. So what's the purpose of what we're doing today? Is changing the functions of that switch in this circuit. Let's have a look at that circuit. The circuit is as shown on the right hand side here, same as yesterday on the previous video, and the switch is connected to RA3 or port A.3, and the configuration of that switch controls the operation of the input on that port. And it could be two states. It can be a master clear, or sometimes called MCRLE as on the screen, and that means that when you push it, it resets the chip. Another function is you can call it the internal master, internal INT master clear, MCRL, and the port then functions as a regular port with some constraints. Well, Great Cow Basic by default sets it up as an internal port, not a reset. And that does that by default. And I've said that twice because that's quite clear. That's the way it works. So what we're going to do today is we're going to look at two parts. We're going to use it as an input, and we're going to initialize it and just check that it is not a reset, and then just toggle the LED. And then we're going to set it up as a reset button. We initialize it, and we'll prove that it resets every time. So the flow is quite simple. Initialize. We're going to flash an LED, and it will do that every time the chip resets. And then if the button is pressed, it will set an LED or not. So in some cases, we're going to see the LED flash, and that's it because it's done the reset. Sometimes it will just change the LED state, and that will tell us that we've changed state from an input and as a reset. So what we're going to do is we're going to go into GC code, and then we're going to look at PickInfo, and it's going to tell us the different parameters, and then we're going to change program and review those results. So let's get into doing that. Here's my desktop, GCStudio, type it in, and it starts it up. And it's already started up, there we go. And I'm taking the chip demonstrations as we have previously. There we go. I'll just turn off the camera for the time being. There we go. This is where we left it yesterday. And I'm just going to shut down the code from yesterday so that we've got an empty screen. Okay, so let's go to PickInfo. Quickest way into PickInfo is press F4, function key F4. And then wait a second, type PickInfo, and it will give you a series of options, but just take PickInfo user, and it will start up. the PickInfo application. And here it is. I've selected the chip I'm using. I can do that down here at the bottom, 16F17126, and then it will then load that chip into the configuration for our review. And I can change it. I can go up and down as much as I like, and it will change the configuration on this tab. Let me just go back to where I want to be on my chip. And why I'm showing you this is because this is the configuration for this chip. It has a lot of parameters, and you're not expected to remember them all, but you may need to change them, and we're going to change them today, one particular one. The ones that are highlighted on the screen now have got stars behind them. They are the defaults that the compiler sets for you. So if it has a star behind it, it means it's the default. And the one we're interested in is MCLRE, and the default is to use it as an internal or INT MCLR. The two options are int and external, internal or external. And so we now know that these are the two parameters. I don't need to go wading in the datasheet to figure out the configuration. And so what we're going to do today is change it from this to that, internal to external. So if I go back to the program, our code, we can see that in the demonstration code that we're going to be looking at. 080 using the reset switch as an input. Double click it, opens it up, and shut down the Explorer. Great. And this time we have got something new on the screen. Well, we've got our regular hash chip 16F17126 and option explicit, always there. Today we've got a config statement because we are going to change the config. And we can pull the config from PickInfo, but I've already put it in here for you. And the options are int or external, internal or external. And if you use the external, then it does mean that you have to use different types of programming approaches. Not going to go into that today, but I will later. But essentially, we're going to test it with the internal, and then we're going to the external, and we'll see the difference. What's different about it is all this is pretty well the same. The constants are the same here, and I've just justified a constant for the reset button on port A3, and I've said that that reset button's it's an input. Now here's our code. If we start the chip, it will flash RC1 10 times. It will wait 100 milliseconds, and this would indicate to us that the chip has reset. Then there's a very simple loop. It says wait 10 seconds. If the reset button is equal to 0, set the second LED RC2 to 1, else set it to 0. So what this means is that when we reset the chip, we will have a flash of 10 LEDs, and then when it's operating, it will then toggle the LED as we push the switch. Let's see that in action. I'm programming it by making a hexadecimal file and flashing it. The LED does flash 10 times. Let's look at that again. I'm going to open up my software to turn the power off on the LED. I'll prove that to you by looking at my desktop. I've loaded up PIC3 software, and I'm going to essentially turn off on and off the LED. Let me move a few things around so that we've got it all in the right place. So when I apply the power, click, the LED flashes 10 times. Do it again. Great. So we've applied the power. I push the button, and that second LED comes on. So we are now using that switch as an input. It did not reset. So if we go back into our code and we change the configuration to the external master clear, reprogram it, go back to the desktop, every time I push the reset, I get 10 flashes, 10 flashes, 10 flashes. So the program is now treating the input as the reset. And I did that by changing the configuration in the source program. You may need to do this sometimes for an event that occurs in production where you need to reset the chip, but by default, we make it an input. Why do we do that? Because it's easier for our users to have it as an input. And if you want to change it to a reset, then you use a command or an instruction in the configuration to change it. And that's all I wanted to cover, is to say that you can change the configuration in Great Cow Basic by adding in #config and then the option. If I go back into PickInfo for a moment, I can actually copy the whole of the configuration out. So if I wanted to use the internal and take all the defaults, I can press copy config, go back into GC code. I'll just delete that that's there for the moment. I can now paste in the configuration, and that is essentially the default configuration. And so it says that a clock that could be output on a port is off. There is no program or data protection. Almost everything's turned off, like low programming, low voltage programming is off. The reset is internal. The oscillator is set to 32 megahertz, and the watchdog timers are all off. And write protect on SAF, which we will look at later, is also off. And you can change any of these or any of the other configuration items by the examination of PickInfo and the datasheet. Well, that will do for today. Let's go back to PowerPoint. So using the reset switch, change the config. Very simple. What we're going to do tomorrow is use that input switch and the ADC, pull the two things together into a consistent program, and we're going to flash the LEDs in sequence as we have before, but we're going to reverse them by trapping that event. After that, we're going to get far more detail. Let me just spend a few moments talking about my hat. My name is Evan Venn. I'm just plugging, I don't get advertising fees, a brewing company in Minneapolis. I lived in Minneapolis. This is not my brewing company, but the guys there we drink the beer there quite clearly. Whenever we go to Minneapolis, we go to the Venn Brewing. So I'm plugging this. If you go past Minneapolis, do drop in at 46 Street there and have a beer or a coffee. You don't have to always drink alcohol. So that's on my logo wear. That's what I'm wearing currently, the Venn Brewing Company, Minneapolis. So, and we'll call that a wrap.